All right. Hello,
Amazing.
everyone. Welcome to the podcast Worldwide Engineers. I'm here with Ayman, who's trying to solve one of the world's hardest and biggest problems we're going to be facing in the 21st century, which is the problem of plastics in the ocean, or basically ocean pollution. Ayman, welcome to the podcast.
Thank you very much for having me, Leon.
Ayman, before you start telling us about how is it that you're trying to change the world by solving the plastic problem in the oceans, I would love to know, and I'm sure the people listening to this would also like to know, what is it that led you to get into this problem and to basically try to tackle one of the largest problems in the world right now?
Mhm. Well, thank you very much, Leon, and also for the question. I actually started, I think it was 3 years ago, maybe four. Um, I was born and raised in Morocco. And so there was a week in which, my family used to drink from the tap water, drink water instantly from there. And so there was a week in which whenever you open the tap water, the whole week, the water that was flowing through the tap was yellow. Um, and and by that time, I was in a program. It's called the Junior Company Program that I had enrolled in. And in precisely in that week, we were brainstorming of what should we do as a project. And so um, I figured that maybe we could start something that not only is for the purpose of us training ourselves to start something, but also to tackle a problem, which is how can we solve the problem of having polluted water? Um, and so whenever we started brainstorming about this problem, the best solution that came out was to create filters.
Hmm.
Why? Because mainly water, if it's polluted, that means that contaminants are there. That means that very tiny particles are mixed with the particles of water. That means that there must be something to separate these particles from the water, for instance, filters. Um, and we started it. It was very good. We started prototyping, and then we did the end product. We started selling in our city. It's a very small city in which I used to live
Mhm.
in, um, and yeah, that's how I was introduced to filters, which is I think they are becoming increasingly important, mainly because of the problem of pollution.
And that led you to start your first product in the water space, which was called the Aqua One, if I'm correct.
No, that was very early on. That was very, very early on. It was called Au Naturel. It was in a mix of French because Morocco they speak also French, but it was a very early product of that. Aquan was just the advance of it. The
So what
I'm
is
still
Aqua
working on it.
One? What is Aqua One then?
Okay, so it started as filters. Okay, so to tackle the problem of polluted water, and then we finished that project. And then I started another one because I knew how important the problem is. I knew how increasingly dangerous it was becoming. My family drinks from tap water. So what happens if the whole week there's no water? You cannot tell me that the alternative is just starve from or dehydration. So
Right.
it's becoming increasingly important. So I did not want to leave it there. I wanted to continue on this journey on creating the and developing it and actually starting selling it and actually try my best to make it a profitable startup. And so then I started with another team. We
Hmm.
separated from the other one, and we started thinking about how can we actually start this startup and how can we introduce these filters. And so the best idea that came out, and this is why I was also interestingly introduced to the plastic problem, because I started as with the water pollution, just pure part of pure water. Well, drinkable water, sorry, that's the word, drinkable water. And then I was introduced to plastics in the ocean. And so we started thinking, okay, how can we make this go on with the filters? And we found out that it will be better if we can introduce filters by first selling bottles. That way you can have your own bottle, water bottle, and then you can buy the filters separately so that you don't only buy the filters, and also so that we can make the filters small so that they can be at low price. So that was the idea, to start with the water bottle, that you can use. And whenever we started thinking more on the water bottle, we found out that one of the problems of plastics is that we use so many single-use plastic.
We do, yeah.
Products, and precisely bottles.
Especially
and
in
so
2020.
It was, huh?
Especially during 2020, a lot of one-time use plastic.
Yes, exactly. And so by introducing also the bottle, not only the filter, we are decreasing the problem of plastic, because we we buy single-use plastic bottles. They are filled with water. We drink of them. They're mainly of 1 liter. Not only that, and then we throw it away. It's just goes away. Then we can talk about the problem of recycling, but it just goes away. And so it's better if we have a bottle already, each one of us, that we can fill it up. And how can we fill it up? With the filter. So that's how we started thinking of it. That's Aqua One.
So the bottle Aqua One has a built-in filter inside of it.
It has the space for the filter inside it.
Which
the filters will come separately, because the filters, one of the problems, let's say, of using filters is that they have to be changed. That's the only problem that filters have, because they have a duration and you have to change them. But they have a long duration if we compare to other things.
Yeah, that was my question. In the case of a water bottle, which is used, 3 liters of water a day on average, how often did you have to change the filter?
Well, it's enough for you to not change the filter until 1 month passes. Yeah.
That's considerable. Average. Which is considerable.
Which is very good, considering that if you buy, for instance, if we compare the fact that you throw away a filter with, for instance, your plastic bottle, averagely we throw, for each human, around we can say 3 to 4 water bottles if you are drinking from not 1 liter, but the other ones, because there's so many categories. So it's considerably far better solution than that. Plus the fact that you can make the filters ecological, which is what we're focusing on.
Yeah, of course. So where is Aqua One right now? Is it still on the market, or did you transition that to your current project you're working on?
We will start selling this summer, actually.
Oh.
Yeah. So where we finished the bottle, now we are planning about the filter. So that's the correct situation.
Oh, that's exciting. Yeah. Congrats. So if I understand correctly, you have 2 projects working on right now. You have the Aqua One, which is the filter water bottle, but you also have your core project, which is what I really wanted to talk to you about today, just because of the scale of it and how technologically advanced it is, which is cleaning up the oceans using the form of filters on boats.
Yeah.
Tell us about that. What is that project about?
Well, this is how I got introduced to the second project. So, it's like we're telling a story here. So that's how I got introduced to plastics, by the bottle. And then I started looking more into the problem of plastics, and we understood how deep the problem is. It's very deep. Because it's becoming rooted in our cycles. That's why it's even in our food chain. So that's a very big problem and mess. And so a couple of friends and I started to brainstorm what can we do to start something else. And we come up with the idea of what if we can stick filters to boats that already move from point A to B? And why? Because that way you make the filter passive. That means that they cannot be expensive, because they will not be guided by by a motor or whatever, because they're just passive. They just stick. And at the same time, it's an effective cleaning, because you just stick it to boats that already move from to different sites, and that way you're cleaning too many areas at the same time. So that's how it started. We started it about a year and months ago. And for the early time, like if we compare it, because it's early, I think we're doing pretty good.
That's such a that's such an interesting idea, having attaching filters to boats that are already moving in the ocean. So it's not like those, because there's a lot of companies and projects out there that are trying to solve the same problem as you.
Yeah.
There's this company, I think it's called Whale or something. They have like a boat that is specialized to pick up plastic. So it's a boat that looks like a whale actually, and it has like a mouth at the front, and it just swallows up the plastic on the surface of the ocean. But you're taking a more passive approach, which is using the already existing network of transportation in the ocean to just, all you have to do is just set up filters on that boat. But then how would it work? How would it work in terms of logistics? Would you just contact cargo companies? Would you contact cruises? Like, how did you plan on executing this? Because I imagine that this would only be effective if you had it on a massive scale where thousands of boats per day would be moving with your filters.
Yeah. Okay. So obviously, before starting, we did a very amplified analysis, let's say, if I'm saying it correctly. We did an analysis of all the projects that are existing, and we found out that they are very good, of course. The problem is we need more of them. It's not enough. But the problem is that they were all expensive to make, because they were all based on something that moves them. For instance, that one, and also there are so many nonprofits that use similar technologies, and even those who use boats to move, I'm not sure what's the exact word, but they move things so that they can collect.
Oh, like a net.
Nets, exactly.
Exactly, yeah.
Nets. They moved it by boats. So they are expensive solutions. Expensive means that they are hard to scale, and hard to replicate. And so that's the approach that we wanted to make. First of all, it's the approach of, yes, we need more of these projects. That's not enough. And the second approach is, what if we can make it passive? What if we can make it low cost? And the best way to make something low cost is to make it passive. And so that's the first point I wanted to tackle. Then the other thing is that, the idea is to first start with small boats. That's the main idea, to start with small boats, so that also we can start developing more very quickly, instead of focusing on big boats with much more problems to solve, mainly hydrodynamics problems. And so that's the first thing. And in terms of logistics, I think if you were referring of like, how can you move the filter and stuff, is that it?
That's something I'm curious about. That is something I'm curious about.
Yeah. So for the logistics, and at first hand, we have to do that. That's why we are still expanding the team. So the idea is, because now we're based in Spain. So the idea is now to start in Spain, and for instance in Valencia, which we are. There's a very big port in here. The idea is for them to cross the Mediterranean, because we're focusing right now in the Mediterranean because also it's a small place. They move from point A to B, and whenever they return, we take, whenever they are at port, we take the filter out, we take the plastics out, and then we stick it again. That's how it should be. But obviously there are more solutions that we still have to think more of it. For instance, having them cleaning, when them removing easily the filter, and then taking the plastics to a garbage can that can be put there, so that they can be sent to recycling. The long-term plan is that we can take the plastics so that we can reuse it. That's the long-term plan of the project. It's not only focusing on creating filters, but also creating our own recycling process, so that we can take away those plastics and not throw them to garbage cans. And also, to make it effective, we are making everything open source. That way, we want people to copy us.
Interesting.
Yes, so that we keep this going. That's the main thing, because the main thing that we want to do is to solve the problem, and we are trying to do everything in our hand to solve the problem.
Tell me about the technology. How does the filter get attached to the boat?
Mm-hmm. Okay.
Like, how do you see that happening, and how does that affect the aerodynamics of the boat? Because, I mean, at the end of the day, the most boat companies, in a sense, if you want to talk large scale, especially cargo boats, all they care about is getting items from point A to point B at the cheapest cost possible.
Yes.
And one of the biggest costs of moving boats is fuel.
Mm-hmm.
So then if you have something that's going to add, 1%, 2%, 3% of extra drag on the boat, that might raise some flags with those companies. So how do you plan to tackle that?
Yeah, very good question. Well, first of all, that's one of the problems of going directly to cargo ships, because not only cargo ships are very big, boats, and it's relatively harder to stick something on them or on something else, or another type of boat. And another thing, because cargo boats or ships, they are focused on fuel efficiency mainly. They're very, very focused on that. It's like each container counts,
of course,
that they have, of course, and it's understandable. But that's why we are starting with fishing boats, because fishing boats already are. They are already planned to be something that drags, so because of the fishing nets. So that's one of the advantages of starting with them. But obviously the idea is to still solve it and scale it to more boats. That's the idea for what we're doing. And well, the final product, we named it Blau 1. Blau, okay, meaning in Valenciano, I think it's in Latin too, blue, because of the idea of we want to recover the color blue of the seas and oceans and waters. And to arrive to Blau 1, what we do is a design process that comprises of many models. For instance, Blau 1 is the 10th model. And to arrive to that, what we're doing is designing and prototyping Blau 0.1, 0.2, 0.3, 0.4, 0.6, 0.7 until we arrive at. And the idea of doing that is to quickly fail. So we can quickly and fast enough learn from the mistakes that we do in one model, and then fix it in the second model, and then fail again in the second model, and the process repeats itself. I think that's one of the processes in which you can innovate better, because innovation at the end of the day is just failing very quickly, so we can know what works, what doesn't work.
Right.
And so that's how we're designing it. We are designing the final product, and through that we're prototyping so many shapes and models. Right now, we're at the sixth model. We're at Blau 0.6. And through that, we're solving every problem that we can encounter, and mainly the hydrodynamics problem. So if I showed you like the models, they are all very different, and it gets, funny enough, it gets even more pointy each time, because we started with something like this, and now it's something like this, to try to solve it. But yeah, that's one of the problems. One of the main problems is hydrodynamics. So we're starting with boats that already are not very hydrodynamic efficient, and they don't care that much. But plus, we're obviously doing our best for it to be as hydrodynamic as possible. And one of the processes we use also in the design is biomimicry, which is bio meaning biology, mimicry being mimic, to copy. And what basically we do is also not only do analysis of what's already existing, and not only, of course, using first principles, which is breaking the problem using physics, but at the same time doing an analogy of nature, because one of the most advanced technologies that exist is in nature, because nature had billions of years of evolution. So it's basically billions of years of testing until you arrive to the final product. And so we also study marine animals, because they are designed to be hydrodynamic. For instance, sharks. And so we try to learn from them, to apply it to the filter, and at the same time mimic them also in the shape of the filter.
I know
Go ahead. For the fact that you said, how can we stick them to boats? That's also what we're trying still to solve, because that's also very hard to solve, because you can solve it, but we're trying to make it as comfortable as possible for them to not be like a big issue for whoever is using the filter. But right now we're testing with magnets.
Really?
That's the main thing that we're testing on.
Because when you think about it, I'm trying to think right now of that with you. The boat is if you want to think about the under of the boat, it's just a metallic surface, and you can't really drill in there. You cannot drill in there.
Yes.
You can't weld anything on there. It's really tricky to play around with that. And then at the end of the boat, you have the rotor, the engine.
Yes.
So you can't have anything, any filter, just loosening up and getting stuck in there. That's going to cause you a lot of headaches with the lawsuits and stuff later on. So I imagine it's a tricky problem. But you said that you're at 0.6 version, so you're getting closer to the perfect model.
Yeah.
When do you plan on having this out on the market?
Well, it's a non-profit, so it's not ideated to be, it's not ideated still to be sold. That's why because we know that we're trying to innovate. So I think the most safe space you can use is a non-profit and not a startup, because a startup, it's far too risky. And in a non-profit, you can fail, but still keep going on. So it's a non-profit, of course. But it'll be out this year, hopefully before November. That's the deadline that we have. So the idea is obviously to try to make it also profitable enough so that we can make the biggest impact we can. But it's a very good start to start as a nonprofit. And the best scenario is to keep it as a nonprofit and separate another one to start it as a startup, so that we can have two.
How are you guys funded? Do you have the government backing you? Is it self-funded? Do you have investors part of this?
Well, we have companies that invest, but at the same time, the university. I think universities are a very good place to seek in investment from, because that's, that's something very related to investigation. So they are the main ones that are investing, but also we have partnerships with other companies.
Yeah, university, especially when it comes to projects that are oriented for sustainability, green energy, all
Yeah.
those things, universities usually try to jump on that because it's also good for their research department and their reputation, because universities care a lot about their reputation.
Yeah, a lot. I can
Yeah.
tell you.
Let's talk a bit more about the general problem of plastics in the ocean.
Yeah.
You're one of a lot of genius people, not genius, but a lot of ambitious people that are trying to solve this problem.
Mhm.
For the regular person like me, like that's not into that space, we tend to not understand how big of a problem this is, because it is not something you can see with your physical eye. It's not like you go to the beach and you see an ocean of plastic there. You might see a bag here and there, but it's not something that's on our mind all the time. So, and I think it's good to remind people of this problem and what are the consequences this could cause in our daily lives. So that's something I wanted to ask you. If the problem of plastic in the ocean continues to grow at the rate it is today, which is alarming, what are the consequences that this is going to cause for regular people like us, for society in general?
Hmm. Um, well, many people tend to blame, and I think that's something that, well, at least I don't like to practice it, which is to blame companies, to blame people.
Countries.
I don't think blaming is the right thing to do. If we analyze the history of plastics, and if we analyze the history of human technological advance, um, let's go back, for instance, whenever cars were made. Cars were actually a response to horses, because we used to use horses, and the problem of growing cities and growing urban sites is that whenever you use horses, excuse the word, but they shit a lot.
Yeah.
So it becomes smelly in the city. That was the main problem. And so the idea was, okay, how can we fix this? Should we create coaches for the horses? Which they did, but that was not enough. And so then innovation happened. Then cars happened, and cars substituted horses. Now a car does not shit. You just have to fuel it. And so, yes, we solved the problem. But now, for instance, there's a problem of CO2 emissions, for instance, and the problem of using fossil fuels. Um, and the problem is because we tend to solve a problem and we create another problem.
Right.
I think it was, I don't remember the name of an author, but he said, for every solution, there's a problem.
Right.
And the main problem, if we analyze this thing, is that we created cars being ecology indifferent. Now, that's the word. We did things ecology indifferent.
What do you
And
mean by
you can,
ecology indifferent?
with ecology indifferent, I mean, you do not think of the environment. You do not think of the impact that the environment would have, because if you go back in time, and whenever cars were created, you cannot tell the one who's creating the car, hey, you're not thinking of the environment. You're like, oh yeah, okay, whatever,
Yeah.
because I'm creating a solution, I'm creating cars. How can you think of that? And it's understandable, because by itself to solve a problem is already very hard, and thinking of something else, another solution, for instance, to be more ecology careful, that's already adding a layer of complexity to the problem, because then you will not only have to create a car, but you will have to create a car that's environmentally friendly. And we're talking
Yeah, and
about
also back then we didn't understand the impact of human activity on
yes.
the planet, so
Mhm.
you can't blame anyone.
Yeah, exactly. So this is how the progress started, just being ecology indifferent, because that was never the case of thinking of it, because that's just another layer of complexity. And then plastics were created. They were named bakelite at first. They were created, I think it was in 1920, I think, or 19. Yeah, it was spread at 1930. It was widespread at that period of time. And I hope I'm not mistaken, but I do know that it's in those periods of times. And so they were created as the perfect material because they were they were cheap. They
Flexible.
had all these great properties. You can put it in food. You can create boxes. You can create everything with them. But they were created being ecology indifferent. And that's the problem that we are realizing now, that we cannot create products without being ecology, careful.
Right.
That's the main problem of it. That's the main problem of plastics. And so obviously they got spread out. And the problem of plastic is not plastic itself. Plastic is very useful. You cannot throw them away. Either ways, how can you create the infrastructure for the water pipes, or for the water city? If you don't use plastic, it's very hard. Although the perfect thing will be a plastic that it's ecology friendly, but it's a very complicated issue. The problem is not the plastic. The problem is the overuse. Because whenever we use a lot something, we pollute a lot, and we tend to destroy ecosystems. And so that's the problem, is that plastic is so used that it's everywhere. And also because it's ecology indifferent, that means that whenever you throw something, let's say you throw a bottle of plastic, whenever you throw it to the ocean, it's not the problem. The real problem is not the bottle. The real problem is whenever it breaks, because everything breaks down. That's why we have to be environmentally conscious. And whenever it breaks down into microplastics, and they become things that are, first of all, toxic, and second of all, they do not disappear. They do not degrade. They only break down into very small particles. That means that another biological being will consume it, and it will stay in its body. For instance, a fish. Now, let's say that fish eats lots of these particles. A, they die. B, we consume them. So the problem comes to us. And that's the real problem of plastics. It's them breaking down into tiny particles. But now it's very clear that in our food chain, we do have microplastics in our bodies. 90% of us, that's already a scientific fact.
Yeah.
I'm not sure for the percentage. I do know that it's widespread in human bodies. So that's the real problem of plastics.
Yeah, it's a huge problem.
Yeah.
And then the only solution to that is taking that plastic out of the ground, because again, plastic is such a perfect material that it doesn't break down. It doesn't degrade. That's how perfect it is in a sense. But that also played against us, where now it is harming us. So then what happens if we continue polluting? Let's say no one is able to solve this problem. Governments will never cooperate together, because this is a global problem that's going to require global collaboration and participation. Like if the US cannot clean up the ocean around the US, or the ocean that's governed by the US territory. That doesn't work like that. You can't clean up a coast, because you're just going to continue having the neighbor polluting. It's a global problem. It's going to require global cooperation. So let's say no one is able to get along. No one wants to solve this problem. What's going to happen if we continue building on that? I want to create a scenario, like the worst case scenario.
Okay. Well, the worst scenario is that we will fuck up this planet. plainly said. No, but well, that's the problem. Okay, if you analyze, for instance, a city or a country, they obviously have services, governmental services to clean the streets. The problem is that the ocean is a no man's land. So nobody takes accountability into oceans, for instance, or seas. Now we are just waking up to this problem and saying, okay, well, oceans are very important. Just 50% of the world's oxygen comes from the ocean, not from the trees. The trees are more overrated than the ocean. And they produce it because mainly of organisms that live in the surface. They called plankton. They are the ones
Right.
who own oxygen. So that's the problem, is that governments are not enacting in that. And that's why it's important for non-profits to act, because they are like the middleman. If there's a problem that a government cannot solve, non-profit. So for now, it's a good thing, but it's not enough. It's far from enough. And I think the best solution is for governments to apply, to have a department that's specialized in cleaning. And for instance, having our project integrated into the government, replicate it, and having filters that clean the ocean and the seas. That's that's the problem. That's the problem of it. But I well, I think that's the best solution at the end for governments to apply solutions that
Collaboration, of
nonprofits
course.
use. Yeah, cooperation. That will be very necessary. It's not only important; it's necessary.
It is necessary.
Yeah.
It is. So what about technology? Do we have the necessary technology as of 2020 to solve this problem? If we do, then what is it that we lack, which collaboration is one of them, to solve this problem? Is it funding? Is it the collaboration? What is it if we have the technology?
Obviously, funding is one of them.
Before that, is technology today, is it enough to solve this problem?
Yes, it's enough. The problem is that we need more. That's the problem. We need more. We need much more. We need more people that are willing to stick their hands, body into the water. That's the problem. And also, it's because it's a boring problem because at the end of the day, what you're doing is cleaning. So for many, it's not exciting enough, and that's why I think also we should we should inspire more. That way we can really make things exciting, which at the end it's just we see it in a boring way because it's cleaning. Nobody enjoys cleaning at the end, but I think we're lacking will to enact. We talk a lot, which is good. We say, okay, this is the problem. Yeah, fuck plastics, they say. That's not enough. It was okay because it enacted things. It may push government policies, but now we need action, and we need more people in it.
We do.
I think that's what we need. But the technology is there.
And I think the best way to get the will is through communication. That's what I love about the internet. That's what I love about podcasting, is being able to connect certain people, certain ideas with a bigger network, a bigger majority of people. And people, at the end of the day, people have good intentions. People want to change the world in a sense. They want to make the world a better place, especially when someone comes from a background that's based on technology. That's one thing I love about being in engineering and leading the worldwide engineering community, is the fact that people that are usually in that space are passionate. Just because of the sheer difficulty of the program they have to go through, only the ones that are so passionate about this are the ones that end up making it out of it. So by default, people have a passion. Everyone wants to, if I ask, like, I often get messages on Instagram of people that this person either wants to start a solar energy startup, this person wants to, work in AI, so it's a lot of things that are that have good intentions, and it's by being exposed to more people like you that are trying to change the world and that are actually in the dirt doing it, literally in the plastic doing it, that's gonna inspire them, you know.
Yeah, and that's amazing. I was following World Engineering, of course, for so long, and I was a very big fan of the page, of course. Um,
Can we
but
talk
yeah,
about
that's
that? It's so funny how we actually got how we actually got to meet. It's I found it really funny. Like you were in a
yeah.
clubhouse room talking about plastic, and I happened to jump on, and I saw you there, and I was like, this guy's interesting. Let me go on Instagram from Clubhouse and send you a DM. So I click on your profile
Yeah, no,
to
I think
send you a
you're
DM.
I think you're doing a great job, man. I really think I really do. And I think it's a very good thing also that you are not only sharing about engineering, but you're also um, exposing uh, people that are engineering things. For instance, that's amazing.
So,
Kudos.
bro, thank you, man. For so, where would you like to send people if they want to learn more about you, more about your startup? You told me you have your website is launching in like 2 hours from now.
Oh yeah, in
But
about 3 hours. Yeah.
yeah, where can
Well,
people go?
well, the name of the nonprofit is called Proluo. Proluo in Latin means to filter. Well, it's a little bit maybe hard to know how it's written because it's Proluo. It has so many vocals united, but obviously it's you can find it at Proluo UPV, which is the name of the university that mainly invests in us. So it's a policy that we have to do. ProluoOPV.com. It will be out it will be out by now whenever
Yeah.
it will be out. But obviously, you can also find me out at Berrayman. That's my main account. Either it's on Twitter, Instagram, or
Clubhouse.
yeah. Thank you.
I'll put all the links in the description.
Thank
Ayman,
you.
thank you for coming on the podcast, dude. It was a pleasure.